Alright, Dr. Lane, so what we have here is a standard forces problem. Now this forces problem is actually a tension problem. And what it is, we can tell it's a tension problem by they give us two strings and it's holding up a 10 Newton force. Now this is a little bit different from the tension problems we did in class because the angles here are actually unequal as opposed to being equal. So we know it's a forces problem, so what we want to do is we want to first draw out all the forces. So I drew this left string here, the right string here, and we have this 10 Newton force pulling down. Now I like to label this right string, I like to label it the T1 force right here, and this one the T2 force. Okay, and then we're going to label this 10 Newton force pulling down. Now, what I do next is label the axes. So we're just going to go ahead and make this the x-axis and this the y-axis. Okay, we have these two axes and just split it right down the middle. Alright, so we know this T1 force has both an x and a y component. So we're going to go ahead and connect this line to the x-axis, making this T1x the x component and this T1y the y component. We're going to go ahead and do that with the other side as well. We're going to have T2x and T2y. Now, they gave us these two angles right here. They gave us a 30 degree and a 60 degree angle. But these angles right here don't help us at all. They're not in the triangle. So what we're going to use basic geometry to find that this 30 degree angle is also equal to this 30 degree angle just by using geometry. You can do the same thing with this 60 degree angle being equal to this one. Now we have everything that we need right here to solve this problem. So we're going to go ahead and we're just going to think about this problem. We know that because nothing's moving in this problem, the forces have to be equal. So just go ahead and write that the F net of x is going to be equal to 0 and the F net of y is going to be equal to 0. Now we know because the F net of x is going to be equal to 0 that the T1 minus the T2 force is going to equal 0. So let's just go ahead and focus just on the x's for a second. Let's look at this graph. And we see that the T1 of the cosine of 30 degrees is going to give us this x, and this is what we want. So just go ahead and write the T1 of cosine of 30, and then we know that it's going to be the same on this side, so that the T2 cosine of 60 will give us this. So we know that the T1 cosine of 30 minus the T2 cosine of that 60 is going to be equal to 0. Now this is very important, so just leave this here. Now let's focus on the y's. We know that the T1 plus the T2 forces are going to equal the forces pulling down, which is that mg, which is that 10 newtons. So let's go ahead and just focus on the y's. So we know that the sine of 30, that we know the T1 of the sine of 30 will give us this side. So go ahead and write the T1 sine of 30. Now let's look at this side. We know it's the same thing. So the T2 sine of 60 degrees. So we're just going to go ahead and write that plus the T2 sine of 60. So we end up with the T1 sine of 30 plus the T2 sine of 60 equals this mg, which is this 10 newtons pulling down, equals 10 newtons. Now, what we have here is we have two separate equations with two variables in them each. What we want to do is isolate one of the equations to find either the T1 or the T2 of the thing, make it by itself so we can use that equation. Okay, so what I start off with the x, so I'm just going to go ahead and solve this x equation for this T1. So take this x equation and just rewrite it. So we have the T1 cosine of 30 minus T2 cosine of 60 equals 0. Alright, let's just go ahead and move this whole minus sign to the other side of the equation. So we have the T1 cosine of 30 equals the T2 cosine of 60. Now, let's solve for this T1, so let's just take this cosine of 30 and put it under this T2 cosine of 60 like we did right here. So we end up with T1 equals T2 cosine of 30 over cosine of 30. Alright, now what we're going to do is we're going to use this T1, plug it into this y equation, and solve for T2. Okay, so just rewrite the y equation. T1 sine of 30 plus T2 sine of 60 equals 10 newtons. We have it right here. So instead of using this T1, we're going to plug in this that we have gotten, which equals T1, we're going to plug this into the whole equation. So we have T1, or T2 cosine of 60 over cosine of 30 times the sine of 30 plus T2 sine of 60 equals 10 newtons. Okay, now what I like to do is just go ahead and divide these and get a decimal answer so you can get rid of that division sign. So we end up with 0.58 T2 times the sine of 30 plus T2 times the sine of 60 equals those 10 newtons. Okay, now just go ahead and add the T1 to the T2, and if you add these together, you're going to end up with 1.15 T2 equals 10 newtons. Now just go ahead and take the 10 newtons and then put this under it, so you're going to end up with your answer of T2 equals 8.70 newtons. Now this is the tension of the T2. However, you're looking for both the T2 and the T1. You only have the T2. So we're not done yet. But we can use this T2 that we got to plug it back into this x equation to find the T1. So let's just rewrite this x equation. T2 cosine of 30 minus, it should be T2 right here, but we're going to replace it with this right here. So minus 8.70 newtons times the cosine of 60 equals 0. Okay, now we're just going to move like we did the first time, move this all the way to the other side of the equation. So we're going to end up with T1 cosine of 30 equals 8.7n times the cosine of 60. Alright, now just go ahead and multiply these together and you're going to end up with 4.35 newtons equals the T1 cosine of 30. Alright, now just go ahead and put this cosine of 30 under this 4.35 newtons, and you're going to end up with T1 equals 4.35 newtons over the cosine of 30. Now, after you divide this, you're going to end up with T1 equals 5.0n. Now, these are your two forces. You have T1 and you have T2. But what I like to do is, because of the fact that you're working with a lot of decimals, you're working with a lot of equations, you could have messed something up and not even known. You could have submitted the answer just like this, not checked it, and the answer could be wrong. So what I like to do is just go ahead and plug these two back into these original equations that you found, and just to see if that, just to make sure that everything's looking right. So I'm going to take this T1, which is 5 times the cosine of 30, minus T2, which is, let's see, it's 8.70 times the cosine of 60 equals negative 0.01, which is basically equal to 0. It's so close. This is just a rounding problem. And you can do the same thing with the y. You can do the 5 times the sine of 30 plus the 8.70 sine of 60, and you're going to get basically 10. So after you do this, you know that both your numbers are congruent to these, and you know that your answer is correct. Thank you, doctor.